Hello everyone, hopefully you're doing well. In this video, we're going to continue with section 1.6, other type of operations. Many real life or real world situations you see, we model it. We can model it in terms of mathematical expressions. I don't know if you noticed this recently. So many people have switched from TV cables to other types of streaming services. I don't want to state them in this video, but so many of them. So a lot of people said, you know what, I'm no longer gonna take the TV cable services, the regular one. We're gonna prefer to do that using streaming services. Of course, a lot of people might ask what algebra has to do about it. So, what sort of mathematical model can be used to describe the hours per week we watch TV by annual income, etc. So, we're gonna try to answer some of these questions right there. So, we're going to solve polynomials using, polynomial equations using factoring. We're going to solve radical equations, solve equations with rational exponents, solve equations that are quadratic in form, solve equations involving absolute value, and solve problems modeled by equations. So, yes, we just talked about TV subscribers or how we can model, the subscribers to streaming services. Polynomials has a lot to do with about it. So a polynomial equation is the result of setting two polynomials equals to each other. Okay, so the equation is in standard form if one side is 0 and the polynomials on the other side is in descending powers of the variable. So when we have a big expressions like, let's say, for example, if we have 5x plus 7 equal to 12, or you have like this equation is of degree of 1 because 1 is the highest exponent. We can have like 6x squared plus 3x equal 11. So this equation is of degree of 2 because 2 is the highest exponent. I can go and on and on and on and many expressions like x power 3 minus 3x squared equal 7x minus 1. As you can see, this equation is of degree of 3 because the highest exponent is 3. Notice that so we said the degree of a polynomial is the same as the highest degree of any terms in the equations, all right? So that's what you see here. You can notice also that a polynomial equation of degree 1 is a linear equation. A polynomial of degree 2 is a quadratic equation. Some polynomial equations of degrees 3 or higher can be solved by moving all terms to one side, thereby obtaining 0 on the other side. So like when we solve quadratic equations, right? On the equations is on standard form, factor, and then set h equal to 0. So that's what we're gonna do. For examples, let's say they ask us to solve something like A. I'm gonna just first of all move up a little bit. I'm hoping we can do that. Okay, and leave some space. We see for this one, we can really, either set, because move all the non-zero terms to one side and obtaining zeros. So what we can do, if we subtract 12x squared from both sides, we're going to have 4x to the fourth power minus 12x squared equal to 0. Now, what is the GCF? We must identify the GCF, the greatest common factor between 4x to the fourth power and 12x to the second power. Looking at this one, we can see that 4x squared is the GCF. So we can factor 4x squared from each term. So we have left only x squared minus what? Yes, minus 3 equal to 0. So if you see it that way, as you can see, we factor each of them like that equal to 0. Now, set each factor equal to 0. Remember, when we set 4x squared equal to 0, we divide both sides by 4. So we have x squared equal to 0 when you take the square roots of both sides. X equal to 0. That's the first answer. For the second one, we're going to have x squared minus 3 equal to 0. If we add 3 to both sides, we end up having x squared equal 3. How to find x? Because never solve for x squared. Never solve for x with a degree more or less than 1. It must be only power 1. So we need to take the square roots of both sides. And remember, the answer must be plus and minus square roots of 3. Okay? So what are the solutions? The solutions, because it was power 4, we could expect to have 4 answers. But because one of them, 2 of them are zeros, we cannot repeat zeros twice. So we're going to have only 3 of them. So we have negative x square root of 3. We have 0 and square root of 3 as the solutions to these equations. If you look at the second equation, so look at this very closely, what you see, well, 2x cubed plus 3x squared equal 8x plus 12. Having something like that, it makes it even more amazing because we already see 4 terms. Each of them has their own exponent. We cannot combine like terms. So what it reminds you, it's the completing, it's factoring by grouping. Remember factoring by grouping? Often ends up factoring polynomials with 4 terms, group terms with common factors, and factor out the greatest common factor from the grouped terms, then factor out the common binomial factor. So look at that. So first of all, what we do, you know what? How about we put it in a different slide because we like space, we like space. Let's use the space we have. I'm gonna just erase this part. Hopefully I can erase it all. Right? Okay. Then I erase this part. Okay. See what we have. We're gonna move all the terms to one side. If you subtract 8x from both sides and you subtract 12 from both sides, what you end up having is 2x cubed plus 3x squared minus 8x minus 12 equal to 0. Remember, the techniques of using factoring by grouping is to combine like terms that has common factors. If I combine the first two, 2x cubed plus 3x squared, and I combine the second to negative 8x, I could do it differently, but you know what? You know what? I'm gonna do it. I think I see different ways of doing it, and it's gonna still work perfectly well. I'm gonna combine 2x cubed minus 8x, they have common factor, 3x squared minus 12. You see this? Still have common factor because the first one we have 2x as a common factor. We have x squared minus 4. From the second one, we have 3 as a common factor. We have x squared minus 4. Our goal is to make sure we have both of them the same because we can factor x squared minus 4 times 2x plus 3. If you forgot why we need to do that this way, please review chapter P, preview. We went over factoring and grouping was one of the techniques we use. Now, let's set each factor is equal to 0. If you set x squared minus 4 equal to 0, if you add 4 to both sides, you end up having x squared equal 4. If you take the square roots of both sides, x equal plus and minus 2. That's your first answer. The second one, 2x plus 3 equal to 0. If you subtract 3 from both sides, you have 2x equal negative 3. Divide by 2 from both sides, x equal negative 3 half. All right. what are our solutions? Solutions would be -2, -3/2, and 2, because we have three solutions. We have three solutions because the equations is in degree 3, because it's x power 3, 3 solutions, x power 4, 4 solutions, x power 5, 5 solutions, etc. So I hope you understand the mechanisms after that. Not the only equations we're gonna solve where you need to group or move all of the terms to one side. We can also do radical equations. A radical equation is an equation in which the variable occurs in the square root. Okay, the variables occur in the square root. Let's look at that. If we have square root of x equal 9, how would you find the x? Well, if you have square root of x equal 9, now to find x, because you always solve for x, you raise both sides to power 2. So square root of x power 2 is x, square root of 9 is 81. Then you find your solutions. We solve radical equations with n-foot by raising both sides of the equations to the nth power, right? So we have square roots of x equal 5. Now, once you have that, raise both to power 2. So x equal 25, right? So that's how we're going to proceed to solve radical equations. Of course, there are some techniques, some steps to follow. You know, when raising both sides of an equation to an even power, it gives you something. So make sure you verify that. So if necessary, you need to arrange them so that when radical is isolated on one side of the equations, raise both sides of the equation to the nth power to eliminate the isolate nth roots, solve the resulting equations. If this equation still contains radicals, so we need to raise to power until we get rid of all the radicals. So check all proposed solutions in the original equations, because not all answers are solutions. Extra solutions may be introduced when you raise both sides of the radical equations to an even power, you know. Well, sometimes the solution is extraneous solutions or extraneous root. That means you said no solutions. Now, look at this one. I'm going to go with two examples where we have that. The first thing we can go with something very simple, but because we are so good in doing this, we're going to do something different. First of all, make sure that, as we said, you isolate the radical on one side. Do not try to have radicals on both sides. So we subtract 3 from both sides to make sure that we only have radical on one side. So we're going to have square roots of x plus 3 equal x minus 3. Remember, we're solving for x. Now, the square root is a big problem. We cannot combine like terms here. We need to get rid of the roots. In order to raise it, because it says square root, if it says cube roots, we're going raising both sides to power 3. But because square roots, we're going to raise both sides to power 2. When you raise a square root to power 2, the roots is gone. We have only x plus 3 left on the right, on the left side. But on the right side, you're going to use that property a minus b power 2. That gives you a squared minus 2ab plus b squared. If you forget, please review the previous chapter. They give you x squared minus 2 times x times 2 give you 6x plus this 3 power 2 is 9. Okay, because it is a quadratic equation, it will be better that we move all the terms to one side. That means subtract x from both sides and subtract 3 from both sides. We end up having 0 equal x squared minus 5x plus 6, right? So if you look at closer, we have x squared minus 5x plus 6 equal to 0 because there is the only one as coefficient for x squared. And we can say two numbers when you multiply give you positive 6. When you add give you negative 5 is x minus 3, x minus 2. Please review and take your time. Of course, I go faster than you. Make sure, verify that multiple times, okay? Maybe, right? I'm pretty sure that's how we're gonna solve it unless we make mistake. We said that. Is that correct? Um, I'm gonna verify again if everything's correct because we subtract 3 from both sides. Have x minus 3 power 2. That gives you uh, x squared minus 6x plus 9, right? So we just want to make sure that what we do is all correct. Okay, let's try it this way. What do you see from there? So we said that we have, I see the problem because negative x, 6x minus x doesn't give us negative 5x, give us minus. So all of this is incorrect. I see my mistake. Not so difficult to say because negative that gives us negative 7x. It's negative 7x, right? Because our problem, I didn't see it was negative 7x. Now, two numbers when you because we're gonna rewrite it as x squared minus 7x plus 6 equal to 0. We would say two numbers when you multiply give you positive 6. When you add give you negative 7 is x minus 6 and x minus 1. Negative 6 times negative 1 give us positive 6. Negative 6 plus negative 1 give you negative 7. Now, let's try it. We're going to have x minus 6 equal to 0. We add 6 to both sides. X equal to 6. That's the first answer. X minus 1 equal to 0. We add 1 to both sides. X equal 1, the second answer. Now, answers are not solutions. You need to plug them, especially when you deal with radical. You need to plug the answers in the original equations to make sure it's solution. So if we plug x equals 6, we end up having 6 plus 3 equal 6. So we agree that would be square roots of 9 plus 3 equals 6. 3 plus 3 is really equal to 6. So 6 equals 6, check. Now, if you check x equal 1, let's try it. Square roots of 1 plus 3 outside equal to 1. So we have square roots of 4 plus 3 equal 1. So 2 plus 3 equal 1. 5 is not equal to 1. So we need to reject this one. So we end up having our solutions is only 6. 6 is the solutions, right? Now, that's one example on how we're going to proceed to solve equations involving quadratic form, all right? Quadratic form. But that's not the only one because if I copy paste again, because one of the techniques we said, oh, you know what? Sometimes you can try to solve it, but what happened is that you still have a roots left. Okay, if you have a roots left, look what's gonna happen. I'm gonna erase. Give me 1 second. All right. First of all, never try to have a roots on the same side each time. Okay, on the same side. You need to move your roots to the other side. Make sure you move at least one of them to the other side. That's what I'm gonna do. Add x minus 3 to the other side. Okay, so we end up having square root of x plus 5 equal 2 plus square root of x minus 3. Okay, so what we do, first of all, we isolate the radical on one side. So because we have two of them, so we need to isolate one of them, right? Now, second of all, we need to square the expressions on the right of the equations and the left on the equations to power 2. So if we raise power 2, the first one look easy, x plus 5 left. But on the right side, we can say the equation is a little bit tricky. Huh? We need to use this property, a plus b power 2. Okay, a plus b power 2. What it gives you, the first one power 2. The first one power 2 is 4 plus 2 times the first one by the second one. 2 times 2 is 4 square roots of x minus 3 plus the second one power 2. Remember, x of square root of x minus 3 power 2 give you only x minus 3. After you do that, we combine like terms. We must combine like terms. We have x plus 5 equal 1 because 4 minus. Remember, we have 4 minus 3 give you only 1 plus 4 square root of x minus 3 plus x. Again, we must do it in a way that we have roots only on one side. So what I'm going to do, subtract 1 from both sides and subtract x from both sides. So when we subtract x from both sides, x is gone. You see we have 4 equal 4 root x minus 3. We can even divide both sides by 4. And we have 1 equal square roots of x minus 3. When you raise both sides by on 2, give you 1 equal x minus 3. If you add 3 to both sides, you have x equal 4. Now, is x really equal to 4? We need to verify. All you need to do, this is the answer. Now, if you want to verify, you plug it back on the original equations where it says, oh, you know what? Square roots of 4 plus 5 minus 4 minus 3 is it equal to 2. Square root of 9 minus square root of 1 equal to 3 minus 1 equal to 2 is equal to 2. Check. So solutions, okay, is x equal 4. Good, 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 good. That's an example. That's a beautiful example. But we still have a lot to do to see equations with rational exponents. With rational exponents, we know that expressions with rational exponents represent radicals. A, like when you do a power m over n, we can rewrite it as a power 1 over n power m, and we know exponent 1 over n is like square n foot of a power m is the same thing, exactly the same thing. So first of all, in order to solve equations in the form radical equations with radical rational exponents can be solved by isolating the expressions with the rational exponents and raising both sides of the equation to a power that is the reciprocal of rational exponents. How are we gonna do that? All right. solving radical expressions in this form, as we said, first of all, yes, we need to verify what we're doing. Let's do the first one. I think we're gonna isolate a little bit. Okay, let's isolate a little bit. We're gonna do, okay, more space, right? We have more space. The first thing to do, solve 5x to the 3 half power minus 25 equal to 0. Our goal is to isolate the first term. So what we need to do, we need to add 25 to both sides. So we end up having 5x 3 half power equal 25, right? Now, after we do that, there are two ways of doing this one, all right? We can simplify both sides, like divide by 5 on both sides. So x 3 half equal 5. That's our first techniques. The second techniques we can do, we can raise both sides of the power to the 2 half power. But instead, I would go with this one and you would see. Okay? So let's go and we write this one as x square 1/2, right? That's the same, over 5. So that means we can write x cubed like this, because 1/2 represents square root, equal 5. How do you get rid of roots? Remember, how do you get rid of roots again? Yes, you need to raise to power 2 to both sides, all right? So what we're gonna do, we're going to raise both sides to power 2. So we end up having x cubed equal 25. Okay? So what would be the answer so far? We need to, how to find x? We need to take the cube roots of both sides. Cube roots. So x equal cube roots of 25. Or if you want to rewrite it, it's either this answer or it can be 25 1/3. So it's either one. So, or I mean 25 1/3, or you can say 25. I mean, what is 25 is 2 power, is 5 power 2. You can do 5 power 2/3. Either ones would work perfectly well for you this way, okay? So either ones you choose to do. Some other examples like B, we can also do B. Going to erase. Yeah, we need to enjoy. Don't forget to go on the book and do more examples. This is a beautiful examples where you can raise to a certain power. I'm going to do B. Well, right now it says A because I erase, but know that even for this one, first of all, let me erase a little bit. Erase. All right. Our goal is to isolate x power 2/3. So we need to add 8 to both sides. X 2/3 equal to 4. Okay. Again, after we do that, as I said, there are multiple techniques on doing it. I see a cube root because I realize I can write x power 2 power 1/3. Remember, power of a power, we multiply the exponent. Okay, so equal 4. Now, for us, is that we have cube roots of x squared equal 4. In order to get rid of roots, we need to raise to nth power. So because it's cube roots, we raise to power 3. So we have x squared equal 4 times 4 times 4 gives you 64. Now, what happened? Okay, we take the square roots from both sides because it's x squared. So x is plus and minus 8. So solutions is negative 8 and 8. Okay? Yes, 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 we can. Yes, we can. All right. You see the examples and quadratic equations that are quadratic in forms. It's very important to see this one also because an equation that is quadratic in form, some equations that are not quadratic can be written as quadratic equations using inappropriate substitutions, right? Especially like if you have x power 4 minus 10x squared plus 9 equal to 0. Look at that one. It looks like quadratic, right? All you need to do is rewrite this one as x squared power 2, still x squared, x power 4, right? Minus 10x squared plus 9 equal to 0. So just realize if you replace everywhere you see x squared, replace it by another letter. Let's say y. So we're going to have y squared minus, remember this one right there, is y because we say y, x squared is y though because we have another square here. So plus 9. See, already have something that you can rewrite. But of course, how you're going to multiply and divide, I mean, how you're going to solve it later, we would see this in an example. But don't forget, when you solve equations like this, always look for the highest degree. If the highest degree is 4, then you're going to have 4 solutions. If the highest degree is 2, we're going to have 2 solutions. If the highest degree is 1, we're going to have 1 solution, etc. All right? Now, whereas in terms of definitions, we said an equation that is quadratic in form is one that can be expressed as a quadratic equation using an appropriate substitution. That's what we just said. So both of the we will see that. Now, let's see equations that are quadratic in form contain an expression to a power. The same expression to that power squared and a constant term. So that's why we said we let y equal x squared, but we could say u equal x squared. Look at these examples very quick. Maybe we're not gonna do all of them because too much to do in this chapter. All right, look at this one. First of all, we know we can have these equations rewrite as x squared power 2 minus 5x squared plus 6 equal to 0. If you let u equal x squared, then you can rewrite it as u squared minus 5u plus 6. But if you want to write u squared minus 5u plus 6 equal to 0, now it's become a quadratic equation, very simple. If it's that simple, then you know you can factor it u minus 3 times u minus 2 because 2 numbers when you multiply give you that positive 6. When you add give you negative 5 is now if you set each of them equal to 0, u would be equal to 3, u minus 2 equal to 0, u would be equal to 2. But remember we said it's u equal x squared, right? Recall u equal x squared. So that means x squared would be equal to 3. If you take the square roots of both sides, x would be equal plus and minus root 3. X squared equal to 2. When you take the square roots from both sides, x would be equal to plus and minus root 2. And now, what are the solutions? The solutions is all these answers. Negative root 3, negative root 2, and root 3. See? Power 4, 4 solutions. Power 3, 3 solutions. Power 1, 1 solutions, etc. Right? Okay. You say this one. How about we do another example? It's very important to do it because I don't know why I raised my voice that high. But you know what? It's important to raise my voice because you can hear me. I try to wake you up. Okay? Uh, let's do this. The second one. Solving an equation quadratic in form. First of all, notice that the equation contains an expression to a power, the power 1/3, right? The same expression to that power squared. So that means if you want, you can rewrite this one as 3x power 1/3 power 2, if you agree, 11x 1/3 minus 4 equal to 0. Now, if you let u equal x 1/3, that means you have 3u squared minus 11u minus 4 equal to 0. Of course, we're going to have multiple techniques on using this one. You can use the AC methods if you want, but I can tell you exactly how we can factor these beautiful equations. But, completing the square could be the best techniques. But you know what? If we do trial and error, because we know it's going to be 3u times u to make it 3u squared, negative 4 would be negative 1 times 1. The reason why I do it this way is because 3 times negative 4 is give you negative 12 plus 1 is give you negative 11. So at some point, I know already how to proceed to do all of this. Now, look, we have 3u plus 1 equal to 0. U would be negative 1/3. And we have u minus 4 equal to 0. U would be positive 4. Remember, we said u equal x to 1/3. So if we said x 1/3 equal negative 1/3, remember 1/3 means cube roots of x equals negative 1/3. So if we raise both sides to power 3, we can do that only because the index is odd, because if it was square roots, we wouldn't be able to do it. So we're going to have x equal negative 1/27. But if it was square root, we would say no solutions. Now remember, we said x 1/3 equal 4. That means cube roots of x equal 4, raising both sides to 3, x would be equal to 64. And those are our solutions. Plus and minus 64, or no, cube roots, 64. So we have negative 1/27 and 64 as our solutions. If that makes sense to you, then it makes sense to me. Remember, it's quadratic in form. If you look at the last examples, let's do the last examples. I need to erase those first. We're gonna erase those. All right, look at this. We have, if we let u equal x squared minus 4, all we need to do, we write this one as u squared plus u minus 6 equal to 0. We know two numbers when you multiply give you negative 6. When you add give you positive 1. It's 3 times negative 2. So we have u equal negative 3 plus 3. Adding both sides give you negative 3. And you have u minus 2 equal to 0. It's going to give you u equal to 2. Now, these are the two answers. But remember, u equal x squared minus 4. So that means we're going to have x squared minus 4 equal negative 3. If you add 4 to both sides, we're going to have x squared equal to 1. Okay? If you have that equal to 1, when you take the square roots of it, both sides, x would be plus and minus 1 as a solution. Okay? So we're going to have x minus 1 as our beautiful solutions for this one. If you agree, we can continue. The second one, we said u x squared minus 4 equal 2. If you add 4 to both sides, x squared would be equal to 6. Taking the square roots of both sides, x would be plus and minus square roots of 6. Solutions, as you can see, negative square root of 6, negative 1, 1 square root of 6 is 4 solutions because, as you see, x squared power 2 would give us a power 4. Okay? All right. Understand quadratic in form. We also have a few other examples to show you, especially equations involving absolute value. The absolute value of x describes the distance of x from 0 on a number line. To solve an absolute value equations, we rewrite the absolute value equation without the absolute value bar, right? So if we have absolute value of x equal 3, all right? So we know x can be equal to 3 or x can be equal to negative 3. Two answers. We know that, all right? This means that determine real numbers whose distance from the origin on a number line is 3. So it shows really, we have two answers. So to generalize it in forms, if C is positive real numbers and U represent an algebraic expression, then absolute value of U equals C, okay, is equivalent to U equals C or U equal negative C. Let's see this in examples. We have two examples here we can use. The first one, first of all, we can look at this. We said, you know what? We can have two equations here. Anytime you deal with absolute value, you have two equations. We have 2x minus 1 equal can be negative 5 because, so if you add 1 to both sides, we give you 2x equal negative 4. If you divide 2 by 2 from both sides, x equal negative 2. That's the first answer. The second answer, that's true. Plug negative 2. You would see, if you plug negative 2 here, you would see 2 times negative 2 minus 1. That gives you absolute value of negative 4 minus 1. That is absolute value of negative 5 is 5. So answer correct. The second equation is 2x minus 1 equal positive 5. If you add 1 to both sides, it gives you 2x equals 6 divided by 2 from both sides, x equal to 3. Beautiful answer. If you try to plug this one in the original equations, give you 2 times 3 minus 1 equal 6 minus 1 is absolute value of 5 equal 5. True. That is true. Now, if we go with okay, we need to state the solutions. What is the solutions? The solution is negative 2 and 3. Both of them verify the absolute value equations. We copy, paste, and we erase everything to make sure we can do B. let's copy paste and redo B. We erase part A. All right. Here also, what you can see, because we have negative 20 on this side, we need to add 20, isolate the absolute value. So we have 4, 1 minus 2x equal positive 20. Remember, the only times absolute value of x equals c is equivalent to x equal negative c and x equals c if there is no constant real numbers in front of the absolute value. So we need to divide by 4 for both sides to make sure on one side you have only 1 minus 2x and absolute value equal 5. Everything we're planning on doing here is possible now. You can say 1 minus 2x equal negative 5. That's the first equation. If we subtract 1 from both sides, it's going to give negative 2x equal negative 6. If you divide by negative 2 from both sides, x equal to 3. First answer. Second answer, the second equations, we can say 1 minus 2x equal positive 5. If you subtract 1 from both sides, it gives you negative 2x equal 4. Divide by negative 2 from both sides, x equal negative 2. So solutions, after you check it in the original equations, you can state that the solutions is negative 2 and 3. I don't verify because I already see it's going to be correct, but please feel free to verify those every time. One more thing to complete the sections. For example, if they ask you the formula h, that is negative 2.3 square roots of I, okay, plus 67.6 models weekly television viewing time, h in hours by annual income, I in thousands of dollars. What annual income corresponds to 3.1 hours per week watching TV. So you see, this one is really telling you a lot about our behavior. First of all, verify what is 31.1 represent. Yes, it's H, the hours you watch. So you're looking for income, okay? I. So what you're looking for is I. All right. First of all, you substitute h for 33.1 equal negative 2.3 square root of I plus 67.6. You need to subtract 67.6 from both sides. Okay? You end up having, when you subtract these like that, you have negative 34.5 equal negative 2.3 square roots of I. Let's divide both sides by negative 2.3. Negative 2.3. What we end up having, 15 equals square roots of I. Now, how do we obtain for I? Yes, raise both sides to power 2. So what is I then? I is 225. So an annual income of, because they said in $1,000, $225,000 corresponds to 33.1 hours per week watching TV. Okay, watching TV. All right, so I think that's it for this section. So we're gonna come back for more linear inequalities and absolute value inequalities. Hopefully you can use these to continue working on your assignments and get ready for any upcoming tests. Let me know if you have any questions. I'll see you in a different video. Take care.